Hello, everyone, and welcome back to the Cisco Optics Podcast, where we talk about pluggable optics for networks. Cisco's 8000 series router changed the game in high-end routers thanks in large part to the Silicon One ASIC. It also introduced to the industry some of the first 400 gig ports along with Cisco's QSP-DD form factor pluggable optics. This is episode 29, and we begin a new conversation with Amar Khan, product management leader for the 8000 series router. We begin with his background in networking and ASICs. Amar received his BSEE at the University of Oklahoma and an MBA from Santa Clara University. He started his career as a member of the technical staff at an ASIC emulation startup, where he worked on cutting-edge ASIC and FPGA designs. His first foray into networking system design was at another startup based out of Massachusetts. He then moved to Broadcom through the company's acquisition and launched and managed products with over $250 million in revenue. In 2010, he moved to Ericsson's IP division and defined their Edge router line with an annual revenue of over $150 million. Amar joined Cisco in 2018 and has been with the 8000 series router team for over 4.5 years. He has worked on various areas of the 8000 product line, including fixed and modular systems, line cards, fabrics, optics, platform security, and more. If you haven't already, please subscribe to this podcast. On Apple Podcasts, you would click the plus button at the top now. We're part of the Cisco Podcast Network. Check out our blog at blogs.cisco.com and search on hashtag Cisco Optics Blog, all one word, no hyphen and no spaces. You'll find podcast notes and links there too. For our YouTube playlist, go to youtube.com and search on Cisco Optics. And for product information, go to cisco.com/go/optics. And now, join me as I talk with Amar Khan. I wanted to start off just by just asking you a little bit about your own personal background, like what your background is and how you came into Cisco and optics.
Sure. So Pat, my background is, I'm an engineer. Obviously, I did a lot of ASIC design work and a lot of application engineering, and then I moved into product management. And I've been with Cisco, for last 5 years. But prior to that, I was with different companies doing product management. So that's basically my background.
Okay. And your product management, I think I saw on your LinkedIn, it's all with like routing, right? Routers?
Correct.
Is that accurate?
Yes, this is accurate.
Okay.
So I started out, go ahead, please.
Go ahead.
I was going to say, I started out doing, some ASIC design. I was actually in a company doing emulation, and then I transitioned into silicon marketing. So I worked for Broadcom and Marvell, and then a small startup doing some really interesting work in the areas of system design, where you would have traffic managers and switch fabrics and NPUs. And then from that point onwards, I moved into system design, system product management, and my first foray into system product management was with Ericsson, and then from there I moved to Cisco.
Okay, so even at the ASIC level, you were in networking.
Yes, absolutely. I did a lot of work specifically at Ericsson because there was a company that Ericsson acquired. They were doing a lot of NPUs specifically on subscriber management. That was their big strength, and the name of the company was Redback Networks, and we came through.
Oh,
Redback.
I remember that.
Yes,
they were on 237, I think, right?
That is correct. That's exactly where that's exactly where Ericsson's IP division was until they moved, and now they're in a different place. But that's exactly where I started. But prior to that, I was doing product management on networking ASICs at Broadcom and Marvell. But then real thing where systems and all ASIC designing and ASIC design specification all came together was at Ericsson.
So, a lot of times when we talk about a router, my impression is we're really talking about the ASIC. That's just the heart, the engine. Is that true?
That is true. And when we go out and we talk to our customers and we do presentations, we talk about our products, inevitably everybody starts talking about, well, what ASIC do you have? And I think that is driven primarily by the competitive environment that we're in. Everybody talks about their ASICs. Broadcom has ASICs. You have merchant silicon, and so and then obviously we have ASICs that we develop. And ASIC is indeed a very important piece of the puzzle, and it's a very important technology. And there is so much innovation that has gone into all the ASICs that we have done in the past and the ASICs that we are using with the 8000 family. So yes, it is. You're right. It is a very important component of the system. So people do talk about that.
I mean, any feature of the router has
Mhm.
to be designed into the ASIC, right?
Correct. So there is,
Right.
from a system perspective, there are many areas that all have to, it's a convergence of so many different things that at a system level that you have to do. Like so, and this is where I I find, and so optics are part of it actually, by the way. So I find that fascinating, and it's very. I think it's just so much fun. I really enjoy that part, that all of this system level stuff has to come together, and
Mm-hmm.
you see that innovation is happening in each and every of these components. So let's just really quickly just describe what it is, right? So silicon is obviously one of them, but your
Mm-hmm.
software is a very important component, your software stack,
Ah, okay. Yeah.
all the routing and switching and ACLs and policing and all that stuff that you enable. Some of that is obviously residing in the ASIC that you have to enable. The ASIC is an important component in the sense that, it does the forwarding and it does all of that at line rate and all that stuff, and how you take all the resources that you have on the ASICs and how you manage them and how you design them. That is very critical. So Silicon One architecture, for example, and I'm not going to go into selling mode or marketing mode, but
Sure.
Silicon One, for example, is, in my opinion, based on my experience as an ASIC designer, is by far the best silicon that you have in the market because there is so much innovation that has gone into it. ASIC designing specifically for networking is extremely challenging.
It,
And
so innovation, can you give an example
yes,
of?
of course.
Okay.
So if you look at Silicon One, for example, one of the key things that our architects decided, and that was a very pivotal decision, was that for us to be able to address needs of our customers as they move forward and venture into 400 gig, 800 gig, 1.6 terabit speeds, you have to make sure you keep up with that, that speed. How do you do that? You do that by not using any memories that are just sort of hanging off of the chip. A lot of times, you have your databases that are hanging off of the silicon. You have your buffer memory because packets are coming in. You have to buffer them, process them, and then take them out.
Mm-hmm.
And a lot of time people, what have they done is that they would take the buffer memory and put it outside because you need a lot of buffering. So that intelligence of how to manage buffering and making sure that you can utilize the buffers that are inside the ASIC and fully utilize them. That was the most innovative thing, in my opinion, that our team did.
So by making
And
that buffer memory internal, does that make
correct,
it easier to manage, or can you
it's
do more sophisticated things in the management?
that's correct. So it makes it that there is a lot of heavy lifting that is happening behind the scenes under the hood, but it makes it very simple for ASIC to scale up, right? So you're not limited by, for example, going out of the ASIC to get buffer memory or place your packets in the buffer memory that's hanging off the ASIC. So that trip that you take by going outside the ASIC, you
Mm-hmm.
take a performance hit because of that.
Performance because there's latency involved,
There is latency involved. You're going through SerDes, and SerDes has its own latency, and you're doing a lot of transactions very, very quickly,
and I would
and that
imagine
all
power
adds up.
consumption. Is
That's
that
power
another hit?
consumption goes up. There is additional design penalties in terms of board, in terms of latency, because you're going in and out a lot of very, very fast. To be able to take all of that and just integrate that into the ASIC and do that very efficiently and come up with an architecture where all ports have full accessibility to that memory and be able to increase the memory size and then add additional memory, which is what we
Mm-hmm.
call HBM, high bandwidth memory, which is just like stacks of DRAM that we add,
Mm-hmm.
and just keep that in package. is the most critical thing, and be able to then utilize that memory effectively, and then also utilize that memory for scalability of your data structures. That would be your longest prefix matching capabilities, or your IPv4 v6 address lookup. All of that is the key innovative technology that we have introduced. And
Can you say that one more time? What is the key again?
so that is the key
Those
technology.
protocols?
Right. Just the architecture of the data structures and memory and placement of memory and integration of memory in package and in on chip is very innovative. Nobody else is doing that. And let me just give you an example. So because it's a complex topic, but let me just give you an example so that
Okay.
there is some context here. So our generation one chip, first gen chip that is in 17 nanometer technology, 16 nanometer, sorry. We did that, back in 2018, 2019, and it is 10.8 terabit full throughput.
Okay.
Today, the latest, greatest chip that we have from merchant silicon vendors does 7.2 terabit. And the one that we have from competitors who are doing silicon internally in-house, it's 5 terabit, and that is their latest, greatest technology.
Wait,
And
say that again. The 2018 16 nanometer technology was how many?
10.8 terabit.
Okay.
And then when fast forward, right? So we are now on Gen 3. So we have moved on to 19.2 terabit. And
Okay.
another chip, I can't remember exactly, it's I think 25 plus terabit. And our competitors today are coming out with ASICs that will do 7.2 terabit, 5 terabit.
Oh, okay. I
So
see.
that is the amount of gap we have. And we have moved on from 16 nanometer to 7 nanometer, right? And there are so much to gain. There is so much to gain when we make the transition. We have obviously increased the resources that you have on chip, meaning buffer size, other resources that we use, TCAM, SRAM banks, and so on and so forth. And then we have also increased the capacity, right? So we started out with 10.8, we moved to 12.8, and from there now we are at 19.2. So there is obviously a lot of development work going on in increasing the throughput so that we can make systems that our customers can use effectively. One of the most important things of increasing the capacity is that we are able to increase the capacity, yet we keep the power profile low. So, it's the power density, the amount of power that you can consume, with this much capacity. So that makes our systems very unique. And I find that truly it's amazing. So that's one part of it, right? So that's the ASICs. But then look at the software. There's so many
That was the first part of my new conversation with Amar Khan. Next time, we'll get into the 8000 routers innovation outside of the Silicon One ASIC. Subscribe to this podcast, and we'd really appreciate you helping to get the word out. Share this with friends and colleagues that come to mind when you think of network technology and optics, and leave a review on Apple Podcast. We're also on all the other major podcast platforms. You may see the Cisco Podcast Network come up when you search for Cisco Optics Podcast. That's where we live, and you can find other great podcasts there too. Also, check out the Cisco Optics blogs at blogs.cisco.com and search on hashtag Cisco Optics blog, no spaces and no hyphens. We also have educational videos on YouTube. Just go to youtube.com and search on Cisco Optics. Thank you for listening. This is Pat Chow, Product Manager at Cisco Optics. The next episode is part 2 of my conversation with Amar Khan. Until next time.